We're doing quadratic inequalities to make sure that you set the equation being compared to 0. And again, what we're going to do is we're going to factor these out, and we're going to see what makes each factor become 0. So when something becomes 0, it's either going from positive to negative or negative to positive. That's when you change back and forth from being greater than 0 to less than 0 or less than 0 to greater than 0. So we want to find out where these breaking points are to where we change our value from being greater than or less than or vice versa. So again, we go to factors, we get 3x and 3x here. Now, this is going to probably be -1 and -1. So, again, compare that to 0, double check it to make sure this works. 3x and 3x is 9x squared. You've got -3x with -3x is -6x, -1 and -1 is +1. So we actually get this value here. I'm going to bring up a term. Do you remember what that exponent right there was called when we were doing these values, trying to find out how many zeros there were? Start with an M. It's a multiplicity, very good. So this is the multiplicity here. This has a multiplicity of 2. So if you remember from the graph of this was going to be one where you went down and you touched and you turned away. You wouldn't cross the x-axis here if this was a y equals equation. It's not a y equals equation, but it's similar in that if you think about the graph and when it touches and turns away, well, what is everything? Everything's above the x-axis, right? Which means everything is greater than 0 here. So what we're looking at is we're going to look at, well, let's just see. So we get 3x minus 1. Now, I like just to put it compared to 0. Just to find where that point is. And I like checking my numbers on a number line instead of going with the greater or less than, because when you have these multiplicities, that messes that up. So we get x equals to 1/3. So I'll put 1/3 on a number line. Now remember, 1/3 is the only place where this is going to be equal to 0. All right? So I want to check a number that's less than 1/3. Someone give me a number less than 1/3 and we'll check it. 0, okay. So let's think about 0. This would be 0 minus 0, which is, and 0 plus 1 is 1 less than 0. No, so it's false. All right, now pick a number greater than 1/3. 1. All right, so this would be 9. 9 minus 6 is 3 plus 1 is, so 4 is also, right? False. Now, what about 1/3? When we plug in 1/3, we get 0. That's what we said right here. We plug in 1/3, we get 0. So, if you plug in 1/3 and you get 0, then is 0 less than 0? No, it's not. So it's false everywhere. So there is no solution to this problem. This inequality has no solution. So the interval notation, just no solution. All right, now, similarly, when we have and I went over this also with y'all at the beginning of the beginning of the semester, not the beginning of the 9 weeks. This 9 weeks has just begun. But if you have an inequality, if you have an inequality that's rational, it also needs to be compared to 0. Now the first one I'm going to work is going to be compared to 0 at the beginning, but the second one I'm going to work, I'm going to need to set up to where it is compared to 0, because it won't be from the start. But let's take x minus 1 times x plus 2 over x minus 3. And I want to know where this is greater than or equal to 0. All right? Well, it's already factored out. So where are my potential breaks? In other words, where can I change from positive to negative or negative to positive? You're making it harder than you need to. Okay. I'm going to set each factor equal to 0. So I'm going to say we got x equals 1, we've got x equals negative 2, and we've also got x equals 3. Those are going to be my points where I can change from positive to negative or negative to positive. So put those values on the number line. So you've got negative 2, 1, and 3. Okay, now, from this, what's a number that's in this interval here from negative infinity to negative 2? Negative 3. Okay, so I'm going to try negative 3. 0. 2. 4. Okay. Now, are we okay to keep going? All right. I'm not interested in the actual value. I don't care really what f of negative 3 is. It could be negative 28. It could be negative 2. It could be negative 0.2. All I care is whether it's negative or positive. Because I know if it's negative, then it's going to be less than 0, so it's going to be false. And if it's going to be positive, and again, I don't care if it's positive 20, positive 40, positive 0.3. If it's positive, it's going to be greater than 0. So all I'm interested in here is checking the positive and negative. So I'm going to set it up like this. If I have negative 3 and I subtract 1 from it, positive or negative? Negative. Okay, so I'm going to put negative there. All right? Negative 3 plus 2. Negative. And finally, negative 3 minus 3. Negative. All right, so I have a negative times a negative, which is, and positive divided by negative is, it is negative greater than 0. No, so this is false. Now, typically, if I don't have any multiplicities that are even, it's going to alternate. I still want to double check, just to make sure everything's good. So think about 0. 0 minus 1. Negative. 0 plus 2. Positive. 0 minus 3. So I end up with negative times positive, which is, and it's divided by a negative, which is positive. So this is true, right? All right, so I'm going to shade that in. Okay. Now, hopefully, 2 will give me false, but let's just check. All right, 2 minus 1. Which is positive. 2 plus 2. 2 minus 3. Okay, so I have a positive divided by negative. So it's false, right? All right, now finally I get to 4. 4 minus 1. 4 plus 2. And 4 minus 3. Positive. So I get a bunch of positives there. So positive divided by positive is, so it's true. Okay, now I shade it in. Okay, now again, we're to the point where we want to check our 1, our negative 2, and our positive 3. We also want to check positive 3 here. Well, if I plug in 1, I get a 0 in the numerator. And 0 in the numerator divided by anything except for 0 itself would be 0. And 0 is fine to get. 0, negative 2 plus 2 is 0, right? But it's not 0 in the denominator, so I'm good here. But now if I plug in 3 to the denominator, I get 0 in the denominator. So it doesn't matter that it has this or equals right here. If I hit 0 in the denominator, then it's no solution. It's undefined. So undefined cannot equal to 0, so I have to put a parenthesis there. So on a number line, it looks like this. In interval notation, my value is going to be negative 2 to 1, unioned with 3 to infinity. And written like that.
Sorry, can you explain why you used parentheses for 3 instead of a bracket?
Okay, because if I plug in 3, I would get positive times positive, which is positive, right?
Mm-hmm.
But a positive divided by 0 is undefined. Is undefined equal to 0? No. And it's not greater than 0 either, right? So it can't be part of the solution. So anything, this is the general rule here. Anything that ever gives you 0 in the denominator is going to be a parenthesis. Even if it cancels out with the numerator. If I'd had an x minus 3 here and they canceled out, that doesn't matter. If it ever gave me a 0 in the denominator to begin with, it's automatically undefined. Are we good here? All right. So now, let's go to one where it's not set equivalent to 0. Let me get my eraser. Here it is. A rational expression that's not set equal to 0. What's the question?
We're just talking about something.
Okay. All right. So this time I got x minus 3 over x plus 2 is less than 1. Okay. Now, I need to set it as a comparison to 0. So it has to be x minus 3 over x plus 2 minus 1. All right, well, I got to get a common denominator here, so it's x minus 3 over x plus 2 minus x plus 2 over x plus 2. Does that, everybody, we're good here? Okay, so this ends up being x minus 3 minus x minus 2 over x plus 2. X minus x is 0. So we get negative 5 over x plus 2 is compared to 0. So the only place we can change, the numerator's never going to change signs. So the only place we're going to change is at negative 2. So, if we plug in negative 3 here, we get a negative over a negative, which is positive. So it's false. But if we plug in 0, we get negative over positive, which is negative, which would be true. And again, it doesn't matter whether this is or equals or not. Negative 2 gives me a 0 in the denominator, so there's a parenthesis with it. 1 became x plus 2 over x plus 2. And that's the trick to that problem. Is remembering that step. All right. A quadratic absolute value. Now, absolute values are different. Absolute values we don't want to set necessarily compared to 0. They can be, but the main thing we're setting with absolute values is just comparing the absolute value to the number. Now, again, I'm going to change this to an inequality. X squared minus x plus 1 is greater than 3. And also, x squared minus x plus 1 is less than negative 3. Remember, I switch the inequality when I compare it to the negative of that value. All right, well now I have multiple inequalities. They're quadratic, so I'm going to set them compared to 0. So x squared minus x, 1 minus 3 is negative 2. And x squared minus x plus 3, that's also compared to 0. So this is x minus 2 times x plus 1. And this is, let's see, it won't factor, will it? So if it won't factor, then let's go with the quadratic formula. So 1 plus or minus the square root of b squared minus 4ac over 2 times a. All right. This is imaginary. Therefore, we don't need it. But we had to check it to make sure it's imaginary because there was a chance that that would come into play in the answer. So my only values that really are going to be where I could change from positive to negative or vice versa is here. So I've got at x equals 2 and x equals negative 1. So let's put these on a number line. All right, now, remember, I'm going back up to the absolute value to make sure that they work up there. All right, so let's try negative 2, 0, and 3. Are y'all with me here? Okay. So if I plug in negative 2 squared is 4 plus 2 is 6, 6 plus 1 is 7, 7 is greater than 3, so this is true. All right, 0 minus 0 is plus 1, so it's, and then 3, it's going to be 9 minus 3 plus 1, that's positive, so it's true. So we're going to shade these in. Now, this one's not an or equals, so I can go ahead and put the parenthesis here and know that my answer is negative infinity to negative 1 unioned with 2 to infinity. Is there a question about that? final example I want to go over with you is just the domain of a quadratic. Not a quadratic, but a square root. The domain of a square root. But the square root's going to be a quadratic. Like, wow.
No.
Do,
It's okay.
do I need to write it back up there? Okay. It's on the video. All right. All right. Now, what do we know has to be true underneath a square root? Or? Can't be negative. 0. It can't be 0, right? So I know if I want my domain of this, then x squared minus 4 has to be greater than or equal to 0. Well, what do I have now? I have a quadratic inequality. So this becomes x plus 2 times x minus 2. It's greater than or equal to 0. So here we get x equals negative 2. X equals positive 2. Plug all those on the number line. Negative 2 and positive 2. So let's plug in negative 3, 0, and 3. All right, what do I get if I plug in negative 3? I get 9, right? Square root of 9 is, I'm sorry, no, 9 minus 4 is 5. Square root of 5 is a number, right? So this works. All right. What about 0? 0 minus 4 is negative. We can't get a square root that's negative, can we? So it doesn't work. 3 gives me a 5, which I can take the square root of 5, so it's positive. Okay, now think about negative 2 and positive 2. I get 0 when I plug in either of those. Is that okay? Yeah, it is, because it says greater than or equal to 0, right? And it's okay to get 0 under a radical. So for that very reason, I can put a bracket on those two values and get a solution. So in interval notation, I would have negative infinity to negative 2 bracketed unioned with bracketed 2 to infinity. One day I'm going to be able to include infinity, but I haven't quite gotten there yet. Is there a question about that?